All right, let's talk about strengths of covalent bonds. The energy required to break a covalent bond is called the bond dissociation enthalpy, or D. For a chlorine molecule, that would be the delta H required to break that chlorine-chlorine bond. We get more than one bond broken, like for methane. If we break all four bonds, you get carbon atoms and hydrogen atoms. That enthalpy is 1660 kilojoules, but the enthalpy of one of those bonds would be 1/4 of that amount, or 415 kilojoules. That's how they work. Bond enthalpies can be positive or negative. Breaking them is positive, usually forming them is negative, and so we'll work that out with some subtraction. So if this is a table, these are all single bonds. You don't have to memorize these. I'll give you a table on the test, but use these values. We'll be able to calculate the enthalpy of formation by tallying up which bonds are broken and which bonds are formed. For multiple bonds, you can certainly see that they're higher. Multiple bonds are stronger. There's O2, because O2 kind of hangs out as a gas. It's a little different. We can use these enthalpies to calculate the enthalpy of a reaction. Mathematically speaking, we take the bonds broken and subtract the bonds formed. Bonds are broken on the reactant side and formed on the product side. So that's a little bit different than what we did in the thermodynamics chapter. And so you need to keep that straight in your head. So let's look at this particular reaction. Methane reacting with chlorine to form chloromethane and HCl. And we want to know the enthalpy of that reaction using the bond dissociation enthalpies. So if we look at the delta H, I've copied the reaction and I've drawn structures for each one. And it'll be more useful to figure out which bonds are broken and which bonds are formed if you look at the structure. So let's look at the reactant side and figure out which bonds are broken. If you compare this to this, I can look at this carbon-hydrogen bond has been broken. This carbon-chlorine bond has been formed. This chlorine-chlorine bond has been broken. This hydrogen-chlorine bond has been formed. Now, some people do this calculation, break every single bond and form every single bond, but I could break 3 carbon-hydrogen bonds over here and form them over here, and it's going to cancel out. It's a little bit more work to do it that way, but if you have a more complicated reaction, sometimes it works out better to just break them all and then form them back, but you can do what you want. So dissociation carbon-hydrogen, that's broken, plus dissociation of chlorine-chlorine, because that is also broken. From that, we're going to subtract dissociation carbon-chlorine plus dissociation of hydrogen chlorine. If you had more than one of bond of each type formed or broken, you'd multiply by 2 or 3, just like you would in a standard delta H calculation. So let's plug that on in. And so we're going to say 413 kilojoules plus 242 kilojoules. From that, we're going to subtract the, let me see, 328 kilojoules plus 431 kilojoules. And then ultimately, you're going to run that all through your calculator. So when you run that calculation through your calculator, you're going to get a negative 104 kilojoules. And that would be your answer.